our final part of our semester exam reviews. We'll start with question 60 and go all the way up to question 75. So question 60, it says the chart and graph below represent the number of weeks Jan was in swimming class and the number of seconds Jan was able to hold her breath. And then it gives us a graph here, and then it says write an equation for the line of best fit. So what we're going to do is we're going to use our graphing calculator. I'm going to reset my memory, clear it all out, and then stat, edit, and I'm going to enter my x values in L1. So that's 4, 5, 6, 7, 8, 9, and then in L2 I'm going to enter my y value. So I have 42, 45, 52, 55, 56, and 62. Enter. If you notice, there's not a constant rate of change between these values. That's why we have to find the line of best fit. So we enter the data first, and then we go back to stat. We go over to calc. So we arrow over, and then we want number 4. We want a linear regression. And then we say, well, we put the data in L1, so we do second 1 will give us L1, comma, second 2 will give us L2. We do comma again, and then we go to the vars button. We arrow over to y vars, and we want a function and y1. So we're gonna get our data from L1, L2, and store it in y1, and then you hit enter, and it will give you your linear regression. It says y equals ax plus b. A equals this 3.8857, and b equals 26.7428. So we're going to round these numbers. So we're going to say a equals, we can say we'll round it to the tenths. So we're going to say a equals 3.9. So we have y equals 3.9x, and then b, if we round that to the tenth, so 26.7. So plus 26.7. So it doesn't tell us what to round to, so we could have said we could round to the hundredths, we could round to the ones. Any of those would be acceptable answers. The next one, in the context of this problem, what does the y-intercept of your equation represent? Well, we know that the y-intercept is always the starting point. So we know that the y-intercept is the starting point. So it's our starting point. Well, in this case, the y-intercept is 26.7. So that means in the context of this problem, the y is the number of seconds we're able to hold our breath. So this is Jan. So when Jan started, she could hold her breath for 26.7 seconds. So when Jan started, our starting point, she could hold her breath for 26.7 seconds. Based on your equation, what's the rate of change? Well, we know that the rate of change is slope. So the slope is 3.9. So 3.9. Use your equation to predict the number of seconds Jan could hold her breath after 12 weeks of swimming. So it says using our equation. So we have our equation, which is y equals 3.9x plus 26.7. And after 12 weeks of swimming, so since it's 12 weeks, we know that x is going to equal 12. So we can plug in 12 for x. So y equals 3.9 times 12 plus 26.7. So 3.9 times 12 plus 26.7 will give us 73.5. So y equals 73.5. So it will take, she can hold her breath for 73.5 seconds. So Jan can hold her breath for 73.5 seconds. Use your equation to predict the number of weeks of swimming class Jan would have to attend to build up holding her breath for 95 seconds. Well, now, since we want to use our equation, we have y equals 3.9x plus 26.7, and it tells us in this one for 95 seconds. Well, we know that is going to be our y value, so we're going to plug that in for y. So we know that y is going to equal 95. So now we do 95 equals 3.9x plus 26.7. And then to solve this, we simply subtract 26.7 and minus 26.7, and 95 minus 26.7 will give us 68.3. So 68.3 equals 3.9x, and then we divide by 3.9. I can just simply hit divide. It'll give me my answer, 3.9, and we get 17.5. So x equals 17.5. So it will take us about 17 and a half weeks. So 17.5 weeks. We go on to 61, look at the table. It says graph the data on the grid provided. So now it's going up by 10, 20, 30, 40, 50. So we might, if we start here and we say that this is 0, 0, we might want to count by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then count by 5s on the other side. So we have 10, 20, 30, 40, 50, 60, 70. And we'll just continue. Alright, so now we can plot our points. We have to plot the point 10 and 30. So 10 and 30 is right here. 20 and 42 is right about there. 30 and 51. 40 and 60. And then 50, 70. Step 2 says write our equation for the line of fit. So we need our calculator. I'm going to reset my memory. Clears it all out. So we do stat, edit, 10, 20, 30, 40, 50, 30, 42, 51, 60, and 70. So we enter our data, and then to calculate it, we go to stat, over to calc, we want number 4, and then we go to second one for L1, our comma, second 2 for L2, our comma, vars, over to yvars, function, y1, and we hit enter, and we get our linear regression, which is 0.98, and A is 0.98 and B is 21.2. So we are going to use those two numbers, so y equals 0.98x plus 21.2. Yes. So now we have our equation, and use your equation to predict a student's score if the student spends 7 minutes studying. So 7 minutes studying. So we know that x will equal 7, so we're going to plug in 7 for x. So y equals 0.98 times 7 plus 21.2. And we can simply just do 0.98 times 7 plus 21.2. So 28.06. So y equals 28.06. So the student would score around a 28%. So the student will score about a 28%. Meaning you should study more than 7 minutes for your exam. 62. Jessica buys a pair of shoes for $32 and 7 pairs of socks. Her total bill is less than $47.75. Write an inequality that best describes the cost. So what we know is that she bought shoes. So she bought a pair of shoes for $32 and 7 pairs of socks. And then was less than $47. So 7 pairs of socks plus our shoes is less than $47.75. So that'll give us the cost of that best describes the cost of 1 pair of socks. So now we have to solve this. So we have to solve this for socks. So we get 7s is equal to 15.75 divided by 7. So 15.75 divided by 7, 2.25, and this should actually be our inequality. So 2.25. So a pair of socks is less than $2.25. Jackie would like her pig to weigh at least 400 pounds by the time the county fair starts, so we want it to be at least 400, so 400 or more. The pig now weighs 120, so it now weighs 120 pounds and gains at a rate of 15 pounds per week. So we want 15x plus 120 and needs to be greater or equal to 400. So 15x, so we can cross off C and D. We want to add, so our answer is A. 64. Given a system of equations, discuss how to determine whether a graph of a system consists of 2 parallel lines, lines that intersect at an infinite point, or lines that are intersecting at exactly 1 point. So if we look at our parallel lines, so parallel lines, they have the same slope, different y-intercepts. Intersecting lines, they have one solution, and they have different slopes. And coinciding lines, they have infinite solutions. They have the same slope and the same y-intercept. They're the same equation. So when we look at 65, describe the graph and state the number of solutions. Well, we notice that they have the same slope but different y-intercepts, so these are parallel lines. And parallel lines have no solutions. When we look at 66, we look at the slopes and we notice that the slopes are different. Well, when the slopes are different, these are intersecting lines. So intersecting lines, doesn't matter what the y-intercepts are, since the slopes are different, they intersect, they have one solution. And then with the last one down here, since it's y equals y equals y equals y equals, well, we need to write this in y equals. So what we have to do is subtract the 10x. So we get 5y equals negative 10x plus 30 divided by 5. So we have y equals negative 2x plus 6. So when we look at these two lines, we notice they have the same slope and they have the same y-intercept. So these are coinciding lines. And they have infinite solutions. They're the same line. You notice they are the exact same line. Y equals negative 2x plus 6 and y equals negative 2x plus 6. 68 and 69 says to solve these. When we look at 68, it's set up x and x's, y's and y's. So we want to use the box out method. So if we want to box out our x's, when we go to box them out, what we notice is they're both positive, so we need to make one of these negative. So I'm going to make everything in the bottom negative. So it's going to be negative 3x minus 6y equals negative 14. And then We have 3x plus 8y equals 20. So now I can box out my x's. One's positive, one's negative. We add these together. 2y equals 6. Y is equal to 3. So once we know what y is, we can quickly figure out what x is. So we have our choose one of the equations. I just chose the top one. We plug in 3 for y. So we get 3x plus 8 times 3 equals 20. 3x plus 24 equals 20. 3x equals negative 4 divided by 3. And x equals negative 4/3. So our solution to 68 is negative 4/3, 3. When we look at 69, once again, we have our x's and y's are lined up. So if we go to box out our y's, well, what we notice is 1 is 3, and this is 1y, so they have to be the same. So I want to multiply this by 3, so that'll give me 15x minus 3y equals 84. And this will give me 2x minus 3y equals 19. But 3 and 3, I need to multiply this by negative 3, so I change all my signs. I box it out. I notice that I have 3 of 3. One's positive, one's negative. We can add these together, so it gives me negative 13x equals negative 65. Divide by negative 13, and x equals 5. So now we got our x. To figure out the y, simply use one of our two equations. So if I have 5x minus y equals 28, I plug 5 in for x. 5 times 5 minus y equals 28. That's a y. So 25 minus y equals 28. Negative y equals 3, so y equals negative 3. So the solution for 69, negative 3, 5. Moving on to 70. An ECR, Johnstown High is selling candy to raise money. M&Ms for $1.50 and Reese's for $2. They sold 50 boxes and made $95. Now we need to write equations. Make sure you write equations. You don't write your inequalities. So we know that x is M&M, so it's $1.50 x plus our Reese's, which is $2 for y, and we made $95. So this is all about the money. And then the next one is our boxes sold. Well, we sold x plus we sold y, and we sold a total of 50 boxes. So we have money, money, and money, and then boxes, boxes, and boxes. Now it says solve these systems. Well, in order to solve these, if you notice, once again, they're set up x's and y's are on top of each other, so we can use our box out method. So I'm just going to rewrite my two equations. X plus y equals 50. And I'm going to get rid of my y's. So I'm going to box these out. If I notice, I want these to be the same, so I want to multiply everything by negative 2. So that'll give me 2 and negative 2. So we get negative 2x minus 2y equals negative 100. And then I'm going to rewrite this one. 150x plus 2y equals 95. We know we're going to box these out. So now we can add everything together. This will give me negative 0.5x. These boxed out equals negative 5. We divide by negative 0.5. And x equals 10. So once we have x, we can figure out what y is. So if x plus y equals 50, 10 plus y equals 50, that means y is 40. And it says to how many of each type? Well, she sold x is 10, so 10 boxes of M&Ms. And y is 40, so 40 boxes of Reese's. this 71 is down here. Joe's Body Shop charges 20 for parts and 50 per hour to fix brakes. Kathy's Body Shop is 70 for parts and 40 per hour, the same work. The same cost at both shops. So what we want to do is we want to look at Joe's Body Shop. So Joe's is $20 for parts plus $50 per hour. And we want to equal Kathy's Body Shop, which is $70 for parts plus $40 per hour. Now we're going to solve this. So we have x's on both sides. So I'm going to subtract 40x minus 40x. So 25 plus 10x equals 70 minus 25. 10x equals 45. Divide by 10. X equals 4.5. So they'll be the same after 4.5 hours. Now we can look at 72, sketch a graph. In order to graph this, we need it to be in y equals form, so we do minus 4x, y is greater or equal to negative 4x plus 2. So we start at 2. Our slope is negative 4, so 1, 2, 3, 4, down 4 and right 1. Or we can go up 4 and left 1. So it's greater than or equal to, so that will give us a line that is solid, our closed-in line. Y is greater than, so we're going to shade above this graph. Sketch a graph of 73. It's already in slope-intercept form, so we start at 3. Slope is a half, up 1, right 2. Or we can go down 1, left 2. Now it's just y is less than, so that will be our dashed line or our open line. So our line is open, and then y is less than, so less than is below. So we shade everything below. And now we have 74. Which set of inequalities gives the graphical solution to the system below? So if we look at, we have two lines, so if I look at this line first, I know we start at 1, and our slope is up 1, right 2. So this is the graph y equals up 1, right 2, x plus 1. Now, when we look at this, we are shading above. This graph is above here, so we're going to be y is greater than 1/2 x plus 1. So we don't need that one. So y equals, or y is greater than 1/2 x plus 1. So when we look at these, we have 1/2 x plus 1, so this is y is less than, y is greater than, y is greater than, and y is less than. So now we know that the second equation is y is, we know it's, if we look at these, it's going to be negative x plus 4. And when we look at this graph, we are below this graph, so we know it's going to be y is less than negative x plus 4. So if it's less than, that means our answer will be B. And when we look at the next one, 74, and our last question, 75. For her birthday, Joanna received a $200 gift card to buy clothes. She bought sundresses and tees. She bought at most 12 items. So at most is a key word there. How many of each type of clothing might she have purchased? So if she received a gift card for $200, that means she can't spend more than $200, but she can spend less than $200 because it's still in a gift card. So we have X is sundresses, Y is tees. So we have two equations. We have one for money and then one for items. Our money, we have $20 for sundresses plus $10 for tees, and we have to spend less than or equal to $200. We can't go over that gift card. And then items, she's bought at most 12 items. Well, our sundresses plus our tees has to be less than or equal to 12 because we can't buy more than 12. Now it says to graph your your system of inequalities. Well, in order to graph this, we have to write them in slope-intercept form. So this first graph, money, to write in slope-intercept form, we have 20x plus 10y is less than or equal to 200. Subtract your x. So 10y is less than or equal to negative 20x plus 200. Divide by 10. And y is less than or equal to negative 2x plus 20. So there's one equation, and then the second equation is easier to solve because y is all by itself, so we just subtract the x. So y is less than or equal to negative x plus 12. So now when we gives us our graph, so what we want to do is we want to start this at 0, 0. So what we're really saying is that the graph's going to look like that, and this is going to be 0, 0. We don't want any negative values in here because we can't buy any negative amount of sundresses or tees. So if 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's the value 20. So we start at 20. So this first graph, actually, I'm going to change that to red so it's easier to see which one is which graph. So 20 is, where was 20? So 20 is right here. So we can change this to red. So if there's 20, our slope is negative 2. So down 2, right 1. So we have our graph of down 2 and right 1. And then the second one is y equals negative x plus 12. So I can do this one in blue. So now we start at 12. 5, 6, 7, 8, 9, 10. So here's 12. Negative x is down 1, right 1. And since it's less than and less than, our shaded region is going to be anything in here. So anything below both of these lines will be the double shaded. And it says list 3 possible solutions. Well, our solutions will be in the double shaded area, so your answers will all vary. So here's one choice. Here's a second choice, and here's a third choice. So this is 2, 2. So 2, 2 is 2 sundresses and 2 tees. 2 sundresses, 2 tees. This is 1, 2, 3, 4, 5. 1, 2, 3. So 5, 3. So X represents sundresses, so it's 5 sundresses and 3 tees. And then the last one is 1, 2, 3, 1, 2, 3, 4, 5, 6. So 3, 6 is 3 sundresses and 6 tees. Once again, your answers can vary. There's a whole bunch of different solutions. When you get these, though, you want to make sure that you have your whole numbers. So you don't want any irrational, you don't want any fractions or decimals, because you can't buy a fraction or a decimal of a t. And that is the end of our Algebra 1 semester exam review packet.